What up, Chem peeps? Who's ready for another free response practice? The formulas and the boiling points at standard pressure for ethane, ethine, methane, and methanol are shown in the table below. Boom. Part A. Draw the complete Lewis electron dot diagram for methane, CH4, in the appropriate cell in the table above. Easy. First, let's determine total number of valence electrons we have to work with. We've got 8 valence electrons, or if we divide that by 2, we've got 4 pairs of electrons to work with. Carbon's going central, surrounded by my other atoms. Connect all of the terminal atoms to a central atom with a bond. Subtract the number of pairs of electrons required to do that. We've used up all of our pairs. Double check, make sure that each element that follows the octet rule does. Carbon's got 8 electrons around it now. Hydrogen, although they don't have an octet around them, recognize that hydrogen is one of those exceptions, and they only want 2 valence electrons. And that's what each of them has got. Feeling good. Subpart I. Would you classify methane as a polar or non-polar molecule? Justify your answer. Alright, that can be kind of tricky to do in Lewis structure format, so I encourage you to take a look at the Vesper model. Ooh. Notice that each of the atoms bonded to the central atom is identical, and that there are no lone pairs of electrons on the central atom. The methane molecule is nonpolar because all of the bond dipoles cancel, and the molecule is symmetrical. Boom. Part B. Which of the molecules, ethane or ethine, contain the shortest carbon-to-carbon bond? Explain. Let's take a look at our good friends ethane and ethine. Here's ethane, here's ethine. Notice the carbon-carbon bond in ethane is a single bond, while in ethine it's a triple bond. Ethine contains the shortest carbon-to-carbon bond. The carbons are triple bonded in ethine and single bonded in ethane. Triple bonds are shorter than single bonds. Boom. Part C. The normal boiling point of ethane is negative 88.6 degrees Celsius, whereas the normal boiling point of methanol is 64.6 degrees Celsius. Explain, in terms of the intermolecular forces present in each liquid, why the boiling point of methanol is so much higher than that of ethane. Intermolecular forces present between molecules of ethane include only London dispersion forces. IMFs, intermolecular forces present between molecules of methanol include London dispersion forces, dipole-dipole, and hydrogen bonding. The higher boiling point of methanol is due to the stronger intermolecular forces between these molecules compared to ethane. Boom. Part D. Energy is required to boil methanol. Consider the statement, quote, as methanol boils, energy goes into breaking carbon-hydrogen bonds, carbon-oxygen bonds, and oxygen-hydrogen bonds, end quote. Is the statement true or false? Justify your answer. The statement is false. All of the bonds described are intramolecular, within the molecule. Intra. These bonds are not broken during the boiling process, which is a physical change. Boom. Part E. Consider the Lewis structures for ethine and methanol shown in the table above. Subpart I. Is the approximate HCC bond angle in ethine 180 degrees? Explain. Let's take a look at ethine. We're looking at the bond angle here between hydrogen, carbon, and carbon. Is it 180 degrees? The approximate HCC bond angle is 180 degrees. Two regions of electron density with no lone pairs on the central atom result in a linear geometry with 180 degree bond angles. Boom. Subpart II. Is the approximate COH bond angle in methanol 180 degrees? Explain. Let's take a look. Now our focus is on the bond angle here. Looks like 180 degrees, but is it? This time, remember we've got two lone pairs on that central oxygen atom. The approximate COH bond angle is not 180 degrees. There are 4 total regions of electron density on a central oxygen. 2 bonded regions, 2 lone pair regions. This results in a bent geometry with bond angles less than 180 degrees. Boom! That brings us finally to part F. A Lewis electron dot diagram of a molecule of ethanoic acid is given below. The carbon atoms in the molecule are labeled X and Y respectively. Identify the geometry of the arrangement of atoms bonded to each of the following. Subpart I. Carbon X. Easy. All you gotta do, count up the total regions of electron density. About carbon X, that's 3 regions of electron density. Doesn't matter if it's a single bond, double bond, triple bond, or lone pair, they all count as a single region. And 3 regions of electron density, none of which are lone pair regions, lets us know that the molecular geometry here is trigonal planar. Boom. Flat triangle. Carbon Y, different story. There's 1, 2, 3, 4 regions of electron density. None of those regions are lone pair regions, so here our molecular geometry, tetrahedral. Boom, and we are done.